Okay, we're going to look at two loads on one supply. So the first load is or branch is a Y connected load with 312 ohm resistors. And the second branch is a delta connected load with 320 ohm resistors. They're connected in a delta to a three-phase 480 volt supply. So what is the total current of this circuit? So if I were to put an amp meter right here, what would that read? Okay, we're going to focus on just doing line current IA. The rest of them are going to be the same value because both branch circuits are balanced. So how do we do that? Well, we need to add the two line currents. So we need to add the line current from the Y and the line current from the delta. Okay, and that'll give us our I total. But we have to add them up at their correct angles in order to get our I total. Well, that poses a bit of a problem. If you recall, back in delta, we used our voltage, line voltage, or phase voltage, same thing, VAB, as a reference. Over in Y, we use voltage VAN as a reference. So it's pretty hard to add things up when they don't have the same reference. So what reference do we use? So both Y load and the delta load, they have the same line voltages. So we're going to use voltage VAB as the reference. Let me explain that a little bit further. We'll focus in on the Y, as this is the one that changes. So in Y, we would normally draw our phase voltage VA to N on the reference at 0 degrees. We know that in Y, we have both V line and V phase, and they're different. The V line, or voltage VAB in this case, is going to lead the phase voltage by 30 degrees. Well, we need to put that voltage VAB on the reference. So essentially, all of our phases and all of our line voltages that you see have to rotate 30 degrees. Now you can see that we'll have VAB at 0 degrees, and VAN will still be lagging 30 degrees, lagging line voltage by 30 degrees. Now, if I draw this out, this is pretty much how I'm going to draw it. VAB will be on the reference, and I'll have to put VAN down 30 degrees. So phase voltage VAN will be plotted at 330. Okay, so now that we know how to change the reference for the Y, let's go ahead and tackle this. So in our circuit here, we've got 480 volts supply. Okay. In the Y circuit, we've got the 312 ohm resistors in each phase. Over on the delta circuit, we have 320 ohm resistors connected in delta. So I like to draw out my circuit first, and I always draw it in this fashion. Basically, A line is up here, B line, C line, and then showing each one attached. So let's go ahead and figure out our values for our Y circuit. Well, we know on the Y side, the V line is 480 volts. So we can figure out our phase voltage by taking V line and dividing it by root 3. So that's 480 divided by root 3. That comes to 277 volt. We can then figure out our phase current. Our phase current is going to be our V phase divided by our R of our phase. So that's 277 divided by 12 ohms, which comes to 23 amps. And I line is the same as I phase. Let's see what that looked like on a phasor diagram. So, on this phasor diagram, I now have to plot it with my reference as VAB. So I put my line voltage, VAB, on the reference. We know that phase voltage is 30 degrees behind it. So I put phase voltage VA to N at 30 degrees. Because these are pure resistors, we know that the current that can flow through these resistors is going to stay right in phase with the phase voltage. In this case, we're going to focus on phase voltage VA to N. So the 23 amps, we plotted on our Phasor diagram right in phase with VA to N at 330 degrees. Okay, so we've got our first line current in the Y. Let's go ahead and look at delta. This one looks a little more familiar, as we're going to use VAB as we always use VAB as the reference. So first off, we can say our V line, while it's the same as it is in the Y, it's 480 volts. Phase voltage is equal to the line voltage, so that's also 480 volts. So we can now figure out our I of our phase. I of the phase would be the voltage of the phase divided by our resistance in each phase. So our phase voltage is 480 volts divided by the 20 ohms. That's going to come to 24 amps. Now, because this is a balanced circuit, I can determine my line current by taking my phase current and multiplying it by √3. So 24 amps times √3, that comes to 41.6 amps. Let's go ahead and plot these values out on the Phasor diagram. So I have my voltage VAB as the reference. My phase current of 24 amps is right in phase with voltage VAB, as that is the line voltage and phase voltage. It's a resistor. So I put that on there. I know that every time I have a balanced circuit, I can use my I line formula of I phase times √3, and that I line will lag I phase by 30 degrees. So let's go ahead and put our line current on there, down 30 degrees from our I phase. Good. Our I line is also plotted at 330 degrees, 41.67 amps. And this one here is 23 amps. Okay, I think we're ready to add this now. I line total equals I line of the Y plus I line of the delta at their angles. So for us, we're going to use just line current A. We could do it with any line current. Let's go ahead and add this up. So IA total is going to be equal to IA of the Y circuit at its angle plus line current IA of the delta at its angle. That comes to 23 amps at 330 degrees plus 41.6 amps also at 330 degrees. Well, it makes it pretty simple when they're both at the same angle. That means we can just add them up. Now, if one of these was at a different angle other than 330, we'd have to add them up vectorially. So in this case, we don't really need to. It comes to 64.6 amps at 330 degrees. What does that mean? Well, if I were to go ahead and put an amp meter in line A right here, it should read 64.6 amps. If I put the amp meter in the Y branch, it's going to read 23 amps. If I put the amp meter in the delta branch, or in the line, it's 41.6 amps. If I put my amp meter in the phase, it's going to be 24 amps. Hopefully this helps you out, and we're going to see you on the next video.